that's it. Let's get started.
Cool. So,
Yeah, the link is better, right?
yeah, it's better than here.
You just need to go to this URL. You need to drop your information there. We'll be doing that right here as well. And then we'll be using a platform called Instruct. How many of you have heard about a platform called Instruct before?
And Katacoda, Killer Coda.
Killer Shell, yes.
Yeah,
like
so it's
any kind of platform that allow you to do hands-on stuff, you know. You have access to a Linux box, you have access to a worker node that's running Kubernetes, and then we'll be executing commands from there, and we'll be doing the hands-on. There will be also one attack, so for those that have never did some kind of hacking, it will be also nice to just try some commands, you know, and try to hack some stuff. It's usually nice.
And another thing that I'd like to mention is the access to this platform, it will be open for the next days. I think it's around 4 or 5 days, I need to check. But if for any reason you want to check this and try this later in your home or anything else, the lab, it will be open and you can just try again, okay? I will just wait for a few minutes before everyone. It's not working?
Yeah, you need to use it from the computer because that link will send you to the page, and then you need to use the computer to type the commands and to do the stuff, you know. So yeah, it's better if you use the computer.
Or if you are a hack, or if you want to use your phone, feel free. But it will be a bit more difficult.
With a guy that had like terminal installed on the phone a couple of years ago. I don't need to say that he was super nerd, right? But it was nice to do some stuff.
So can we start, or everyone copy the link?
Yeah, we can go back to the link as well. And also, it should take you guys a couple minutes because the lab needs to start up, you know. So after you go to this page and then you drop your information, there will be an icon saying start. And then after you click on that, you'll be sent to this page, but in your guys' case, there will be a counter on the left bottom side that says 3 minutes or something. We just need to wait those 3 minutes and then we'll be starting.
Yeah, and for who does not know what is Falco, so Falco is a tool to help you with threat detection in Linux systems. And Falco is a project from the CNCF. It was accepted, and it's a graduated project from the CNCF. And basically, Falco will use syscalls from the kernel, the Linux kernel, to detect and to identify malicious behaviors on your systems. So not only syscalls, but Falco can basically Falco gets some inputs, have some rules that you can validate these inputs based on that rules, and have some notification channels. So for example, do you want to identify any specific behavior in your system that you think is malicious? So Falco can detect, and in real time, you can have a rule that identifies that and notify someone that something wrong is happening. So I'm just giving a quick summary because you'll be able to see here, but it's just to show to you the power that we have with Falco. And another thing that I'd like to mention is you have some plugins on Falco, so you can use as input not only the syscall, but Kubernetes audit logs, and some other inputs like AWS CloudTrail logs, and GitHub audit logs, and a lot of stuff. So it's very, very powerful. I think it's still loading. It's around 3 minutes to load the lab, or something like that.
Has anyone loaded already? Yours loaded? Okay, yeah, let's just wait a couple minutes and then we get started.
I don't know any jokes, so.
Yeah, just a quick question here, like who here works like maintaining Kubernetes infrastructure inside of a company and it's responsible for running and maintaining the clusters? Okay, not much. So how much of you are like software developers, just crafting code every day, just so we know who we are speaking with? Okay, so anyone want to say what do you do in your work while we wait? Who else work with DevOps here? Okay, nice. Okay, cool. You work with DevOps as well? Who else wants to share? En espanhol, se quiseres. Okay.
So just to give you an overview about the hands-on lab that we have here. So basically we'll be installing the Falco in a Kubernetes cluster using a Helm chart. And after install, we'll be able to see a quick example about how Falco can detect these malicious behaviors. And after that, we have something a bit more advanced. So we have this project called like Atomic Red. If you search for this on GitHub, you'll be able to see. But it's a framework to simulate some real-world attacks. So you can simulate some kind of famous attacks and do some labs with that. So the idea is to use Falco to detect the malicious behaviors based on that framework. Yeah, I think that's all about the workshop. Yeah, I think we can start.
Okay, so let's get started. I will sit here. Well, first, that's basically the design of the lab that you have access, right? First, we have a couple of sessions, as you can see here. So we'll be going first through the Falco installation with Kubernetes. We'll take a look on the rules, which is the building block of how Falco works. Then we're going to do all the atomic red kind of thing, which is performing one attack and see what the tool showed to us after we perform the attack. And then we're going to use Falco tailor, which is another software inside of the Falco ecosystem that allows us to actually remediate and take action when some kind of attack happens. So let's say someone tries to steal data from your infrastructure by running a specific command. Falco tailor can remediate and stop that attack from happening. So going back here, in the first page, we have access to a terminal, and if you just type, let me get bigger. Just type here k get poll, you should see some kind of output here, which means that you are connected to that worker node, and we'll be issuing all the commands from that terminal right here.
Now you can sing some Brasilia song.
Cool. So on the right-hand side, you have all the instructions here. So we're going to be using Helm for installing Falco. Helm is a package manager for Kubernetes and allow you to install a bunch of software and configuration with a single command. And then after that, we're going to configure Falco in a specific way. Since it's installed through Helm, we have something called values file, which allows us to specify how we want the software to be deployed. And we're going to show you guys what's the configuration that we have here. So I will be doing this here. Feel free to follow me along or to just do that afterwards. As Edson said, we're going to have this open for 5 days. So you can do that after you go back home and like take a look in a more calm environment. But mainly, I will be using the run option here to just grab the commands and paste in my terminal, right? So I'm running that. It says that it already exists. That's fine. And then I'm going to create a values file. And we can take a look on that file quickly here. So I'm just going to use less. And you see that the configuration is very straightforward, right? We have some configuration here for the driver, which is how Falco will access the underlying infrastructure and syscalls. We have 2 ways of doing that. One is through eBPF, and the other one is through kernel models. Right now, we have been using eBPF since, I believe, the full way of doing stuff, the full way of instrumenting kernel since that time. So we'll be using that. We also have some configuration to access the containerd. We have containerd running here, and containerd is responsible for actually running containers, right? And we need somehow to communicate with the containerd socket that's exposed on this path right here, since we have a K3S kind of Kubernetes, so it's exposed on that path. And we also have Falco Sidekick that honestly I don't know why it's being deployed because we won't be touching about it, but it's here anyway. Now, I will just use this command right here to deploy Falco. and then you should be able to see the pods getting started. It might take some time for them to spin up, and we do have some nice comments here, kubectl wait pods, that will wait a couple seconds so that the pod is actually created. And then after that, we're going to trigger some commands to see the response. Is there anyone that's still loading or that got any kind of problems with the workshop? Cool. The pod takes some time to spin up here because it's doing a lot of stuff. One of the things that it is doing right now is actually trying to communicate with the kernel. And it's done, as I said, through eBPF. So in order to communicate with the kernel, we must use something called eBPF hooks. And it takes some time for us to communicate, to properly create all the health checks and the liveness and readiness probes. And once that happens, we have this log message condition met here, which means we are good to go. And the first thing that we're going to do is we're going to trigger a Falco detection, right? So most of the people here apparently never heard of Falco. So Falco is a software to detect threats. And the way that it does that is by communicating with the kernel and listening for syscalls. And syscalls are basically the smallest thing that can happen inside of a Linux worker node. Whenever you have, for example, ls command being triggered, right? What the Linux kernel is doing at the end of the day is triggering a lot of commands so that it can show you what the files are present inside of that specific directory. And in order to do that, it will trigger a lot of syscalls. And Falco works on those syscall level. So pretty much any command, anything that you do inside of a Linux kernel, and even for Windows as well, but we are not proud of this much because the Falco project is not super good for Windows. But anyway, even for Windows, you might be able to detect these commands. And the first thing that we're going to do here is try to find inside of my root folder anything that has ID_RSA inside of the file name, right? And what does that mean is usually you would store SSH keys within this kind of format. So this person here, which in this case is me, right? This person that's performing the attack is trying to search any kind of SSH key that's available on that worker node. And that by itself should be something that you don't want to run on a daily basis, right? That's something that if there's anyone running that command inside of your company, that's something that must be taken care of. So we're going to run that. You see that we did find a specific file right here, and we can even cat this file here. And we're going to see the private and the public key, right? So whoever has access to this and whoever is trying to list this should be doing something harmful, to say the least. And then after that, we can clear, and then we can see the logs for Falco. So you see that we have some logs here, and we are even grabbing for keys, passwords, T1552, Mitre, or Arcade as pod name, and this is just meant to filter out logs because we do have a lot of stuff that's being logged there. And you can see here that Falco is detecting something, right? So it's detecting that warning, grab private keys or passwords activities found. You can see some more low-level information here, but you can also see proc easy path, which is the process execution path. And as you can see, we indeed use a defined process here. That's the Linux tool that we use it to search for the file, right? We also have some information here from the pod, but in this case, we were running that inside of the worker node itself. So there's no pod information. And then we have a lot of extra information here. So this first part is just showing you guys that Falco is detecting the command, right? And in most of the case, it might be something serious, but also it might not. It might be like one of you DevOps guys just trying to troubleshoot something, you know, and in order to do that, you might need to read the key, you might need to collect data from the key and to run something. So appears that if you need to actually take action on this, one of the things is actually analyzing what's happening there. And we're going to see in the next step how we can have tools like Talon to actually detect and respond to this. But basically, right now we are just showing you guys that we are detecting the command being triggered. We will also, as part of this first lab here, trigger another command, right? So first, we're going to create a pod. The pod is create dodgy pod, esquiva, and then we're going to access that pod. So for whoever here works with Kubernetes, that's a daily kind of work, right? Assessing a pod, execing into the pod, because you need to troubleshoot something. And as far as we know, everything is good. No one is doing anything harmful with the environment. It's just accessing the pod. But a simple action that's assessing the pod, it can be very harmful. Like, if you give me access to your infrastructure right now and you give me access to a pod, I can easily try to compromise your entire system by leaving the context of the pod and assuming ownership of the worker node. And once I have access to the worker node, I pretty much have access to a lot of stuff, right? I can create pods myself, I can create containers, I have access to the container runtime socket. I have a lot of access, especially if we are speaking about a cloud environment. If you give me access to a worker node, that will probably be an EC2 or a VM in GCP or a VM in Azure, whatever. And that EC2 itself will also have credentials to the IAM role. It might also have credentials to the IAM user. So something that might be like a normal day action, it's something that in big corporations you might need to take care of, you know? So after we trigger this simple command here, we're gonna exit the container, right? So we did pretty much nothing. And then we're gonna also use Falco to see if it trigger any command from that execution. And indeed it did, right? So we can see here a shell was spawned in a container with an attached terminal, and we can see here the same information. What is the process execution path? What's the container name? The container name was Alma Linux, the container image latest, and the K8s pod name, which is the pod from Kubernetes, is the dodgy pod that I just created. So in this first session, we used Falco to detect two different behaviors, two different commands that happen inside of that worker node. One is trying to find RSA keys, and the second one is trying to exec into a container, right? And again, as of now, there's nothing happening here in terms of really doing harmful stuff, but easily you can use commands like this to hijack and to steal useful information. We can go to the next lab now. If there's anyone that's following along and doing like hands-on right now, and if you have any problems, just raise the hand, and Edson or me can go and help you to finish it.
Any question or anything? Nothing? Yeah, is it something that Igor mentioned? Like, for now, Falco will be only able to detect and notify in some channel, but we have some other sub-projects inside the ecosystem that can help you to react and to respond. In that case, we will be talking about Talon, and we have a specific task for Talon, but yeah, with Talon you can respond. For example, let's suppose that someone is doing an exec inside a pod, and it's not allowed, and with Falco, for example, you can kill the pod, and it will close the session. Cool?
Any other questions, comments, before we go to the next one?
You say that you can easily leave the context of a pod and can compromise the worker node. So I am not aware of this, and I don't know how can you do that, and why is it a vulnerability?
That's a very good question, and it's actually a vulnerability. So it also depends on the configuration. Like, for example, when you are creating a container or a pod, there's a lot of stuff that you need to configure, like the container security context and the configuration of running as root. But depending on the configuration and if there's any vulnerability present there, there's a lot of attacks that are very, very famous in the world about leaving the context of a container and accessing the worker node. And that's called by container escape. If you just search it on Google, you see a lot of vulnerabilities that appeared in the past that allow you to escape the container and go to the worker node. And that, by the way, is why you have so many projects nowadays, like, for example, Kata containers and the Divisor project from Google that is meant to change how we think about containers and create like a deeper kind of isolation between the container and the VM. Because at the end of the day, even though we see container as a different thing, container is just a process running inside of your OS. From the OS perspective, it's just another process. It doesn't matter if you're running that inside of a Linux namespace, which is by definition what a container is, or if it's just a random process.
Any performance degradations for calls? Performance degradations.
Yes, he was asking if there's any performance penalty of using tools like this. And yes, I usually say that there's no free lunch, right? In order to do this, you need to pay a little bit. But it's very small. Like, I don't want to say any numbers here, but it shouldn't affect the workload. And if there's any like penalty, it would be in the house of the milliseconds, or even like just a single digit milliseconds. There's a study about this. I can send you guys later. But comparing Falco and some other tools that do the same kind of thing. And basically, since you are using eBPF, all the programs that use eBPF, they will have the same kind of penalty. So it doesn't depend on the Falco implementation itself.
And it depends of the amount of changes that are happening, like the amount of syscalls that Falco need to collect. So if there is a lot of stuff happening, it will be more syscalls and more performance you need.
Yes. It shouldn't change anything. Like, of course, if you have a distroless image, you might not be able to exec inside of that image. And even if you do exec, you might not have nothing to actually trigger there, right? You might not have sudo, you might not have cat, and a lot of Linux binary tooling available. But nonetheless, if you can access that container and you trigger stuff there, we're going to capture. That's it.
Yeah, I think we have just one more.
Yes, and that's what Falco Sidekick does. The tooling that I told you guys that I don't know why we are deploying, because we won't be going through it. But basically, there's 3 tools available right now in the Falco ecosystem: Falco, Sidekick, and tailor. Falco is responsible for detecting. Sidekick is responsible for the visualization. So I detected, let's say, 5,000 events in the last hour. What are the categories of these events? Where are they coming from, you know? With Sidekick, and we might be able to show a quick UI of Sidekick here, I don't know, but it's basically meant to provide you visualization. And then the last layer, which is Falco Tailor, which is responsible for reacting to the event. So something happened, I will take an action. Oh, we're gonna go to the second one right now.
O que está mostrando? Ah, só minuto. Oh, 1 second. That's the thing about doing some hands-on stuff.
Okay, cool. That's the Sidekick UI.
Let me open here.
Super, yeah. So every line you see here is an event that's happening. That's this is actually tagged. So for every event, you have some kind of tagging so that you can group then or do some kind of analysis, you know. So here you are saying where the event's coming from. Then it's the level of the criticality of the event, and then the remaining information about it.
Yeah, and another thing, just to close this topic, is by default, Falco is able to send the events only for 6 channels, like the HTTP or webhook and this kind of stuff, but with Falco Sidekick, you can send the event for like almost everything, like Teams, Elasticsearch, or anything else that you want to send. So that's the cool part about Sidekick. Yeah, this is the next topic. So that's cool that everyone is asking something that is the next topic, so we are good. So let me reload here. So the next task that we have here is about the Falco CTL. So Falco CTL is basically a command line that you can use to manage the Falco rules. So the power of Falco is about the rules. So Falco is basically an engine that we receive an event, that we have a policy, and you match the policy with the event, right? So by default, Falco has have a good amount of rules. These rules that we are showing here are basically the default ones, but you can write, your own rules. So if something it's not a malicious behavior for a company A, but for you it's a malicious, you can write your own rule. So that's the idea. So Falco CTL, talking about the artifacts of Falco, we have the rules that I was talking about, like, is it the policy that we will match with the event? So we got the event, we have a policy, this policy is the rule. It's basically an YAML. So for the DevOps guys, it's basically a normal YAML that you already work with, so it's kind of easy to understand. And we have some plugins. So like I was saying, you can have syscalls, but you can inject events from, for example, CloudTrail. So let's suppose that you want to write a rule about a new user is being created on your AWS account. So you can inject the events from CloudTrail, write the rule, and get notified about it. A good use case is about creating secret and access keys on AWS. So whenever someone creates, you want to be notified. So here we have some kind of explanation about it. We are with just amount of time, so just a few minutes. So let me export the name of the pod here. And Igor, do you want to explain about the plugins and?
Yeah. So as Edson was saying, the idea here of these plugins is to actually allow Falco to be extended without changing the code of Falco. So initially Falco was designed in 2018, whatever, to work with syscalls only, right? So you would be able to collect from the data source and then perform some kind of logic on top of that event to determine whether or not you should take action after that. So where we are collecting the event is called the data source, and the engine that's performing the collection is what we call as Falco itself. So Falco doesn't know the data source. It only knows about the engine, and then there's a lot of plugins that allow us to communicate with external data source, collect events, and then perform actions on top of those events. And here you can see all the plugins that are available right now. So we have the default one, which is syscall, allows the kernel to be a data source, send events to us. We have CloudTrail. CloudTrail is basically the API audit from AWS, which whenever you create a EC2, whenever you trigger an API call, the API call will be registered under CloudTrail, and then you can configure CloudTrail to send events somewhere. That somewhere is Falco. So we can collect all the events that are coming from CloudTrail and perform actions using the engine. And the same here applies for all the plugins that we have. There's one for GCP Audit, which is the similar service for AWS on GCP. There's one for Azure as well. There's one for K8s K8s audit for all the major Kubernetes providers. So AKS, EKS, and GKE, and OVH as well. That's one that was recently created. And you can also have the plugin to enriching metadata information from Kubernetes. Also, you can see Kafka here, Okta, there's also GitHub. And the idea is, in order to create a plugin, you don't need to mess with Falco code. Falco is written in C, by the way, and all the plugins are written in Go. So it's actually easier for you to create a plugin than mess with the Falco core logic, you know.
Thank you. I just want to know if whenever you're deploying Falco inside the cluster and you want to connect to the provider, the monitor provider on the cloud platform, are you using any authentication and Falco is able to pull the data, or do you have to implement like a Firehose streaming to get those, to fetch that data and push it into Falco in order to sort what's happening with the events?
Cool. So, for example, for the CloudTrail case, every plugin has a different way of communicating. For the CloudTrail one, for example, you must deploy SQS and SNS, and then through that, you'll be sending data to Falco. So, who is sending the authentication in this case is the IAM roles that you assign to SQS and SNS using the fan-out pattern. And then if you are using GCP, you also need to have some kind of configuration on the GCP side in order to handle the authentication.
Is there a way to extend the monitoring capabilities, for example, integrating Falco with a Datadog or something like that, to export the alerts so we can have this visibility on other OpenTelemetry or monitoring stuff? More complex, maybe?
Yes, I don't think there's anything out of the box right now for Datadog, for example, but we do have a way to send data to webhook. So once you can send data to webhook, you can pretty much craft any code and send data anywhere you want, you know. But there's nothing out of the box for Datadog right now. But the good news is it's just easy to go there and contribute, you know. That's the magic of open source. And I'm pretty sure that someone is thinking about creating this kind of plugin right now.
I see there is just a single node cluster. Does it monitor clusters too?
He was asking if Falco can be used to monitor like clusters with more than one node. And yes, we only have one node here because it's cheaper to run just a single one.
So I think we can. So basically for this task, we'll be playing with the Falco rules and how to install and how to see the plugins and the rules works. Yes. Yeah. So I will not spend much time on this one. Again, it will be open for the next day, so you can play because we want to show how to respond a thread. I think it's pretty cool to respond than just see the rules. So I will be just.
Yeah, Falco CTL here is mostly used to manage Falco, you know. So if you ever need to deploy and run Falco at scale, Falco CTL will be your friend, but it's not actually very fun to see it working.
Yeah, and don't follow my example and do not click on next without doing. So here we will start to play with the Atomic Red project. I will be doing here, but if you want to talk about it, I will be just doing the lab here, and if you want.
Okay. Yeah, so in this one, we'll be performing a more sophisticated attack, which is part of the Atomic Red team. As Edson said in the beginning, the Atomic Red team is a framework for performing attacks, and it's maintained by a lot of companies, and there's a lot of contributors there. In order to actually protect environments, people usually say that you need to understand how to attack them in order to protect. So that's why you have so many people on the secure landscape right now working in this kind of offensive tooling, right? And Atomic Red is just one of them. And basically here, we'll be deploying a pod that's called Atomic Red latest, the image it's pointing to. And this pod has access to a PowerShell. and then we'll be performing some of the attacks available from the Atomic Red Team framework. There's a lot of attacks that you can use there. There's one ID for each attack. You'll notice here on the commands that we'll use that you just use the PowerShell command to invoke it, and then you pass the ID of which attack you want to perform. And they will be doing all kinds of crazy stuff. Some of them will try to perform the container escape that we spoke about, which of course depends on some misconfigurations and vulnerabilities. Some of them will try just to collect any kind of private and sensitive data that's on the node, listing known files that usually have this kind of data, you know, so idea are safe files, any file ending with .aws, any file ending with credentials, and things like that. There's a lot of known paths inside of Linux file system that usually have credentials, and then one of these attacks will be just performing random checks to see if there's data there. It's a very extensive list. I probably never played with either like 10% of them, but if you are looking forward to it, just run this command. And by the way, I don't know which one will be performed here, but the idea is whatever is performed, Falco should be able to detect it. And then we're gonna see on the logs there.
Yeah, so basically, and again, for who likes Windows, we will be using PowerShell. Yay! So for this one, all of these examples of attacks, they are mapped to the MITRE attack framework. So if you don't know what is the MITRE attack framework, I recommend to take a look on this because it's pretty interesting. So for this one here, the first one we'll be doing is, let's suppose that I'm trying to do something malicious, and after finish that, I want to remove all of the steps. So I want to delete the files that I created, I want to remove my history and this kind of stuff. So this is the thing that I'm doing here in this one. So the idea is to prevent that any detection tool will detect that I was doing something here. So let me open here and open the PowerShell pod. So here we have the PowerShell. And I will just import this specific module. And on this side of the screen, on the right side, you will be able to see something really cool that Falco is detecting at real time. So when we are talking about security, attack, it's important to have the detection at the real time, or almost at the real time, because it can take just a few minutes to someone steal a lot of stuff from your environment. So it's really important to have this kind of detection at real time. So I will just play quickly here, not on this screen, this one. Let's just invoke the commands here and run the test. So as you can see, it triggered a Falco rule at the same time that the test was executed. I will not go deep about the test that I'm doing here, so I just want to show to you how fast we can detect that something is happening on your environment. So I will just, again, I'm in the wrong tab, just remove this one. So the first one was to remove, and the second one is specific about trying to modify files like bash rc, profile, etc rc local, and is it one of the technicals for the escalation that you can put, that you want to put something on to execute automatically, and the idea here is to detect if someone is trying to launch a malware or something when you open a session on your shell. So let's do this again, the same process. I'll just invoke, check the requirements, and I'll be running. Let me check here. Yeah, it's the same one because my screen is a mess. But it's basically that. The idea here on this one is just to detect that something happening. So let me go to the next one because we have just a few more minutes. And this is the
And just one thing here while we wait, the thing with like changing those bash files and any kind of file that is meant to configure your shell, the bad thing about doing this, of course, if you are in your local machine and you are doing this, you are probably trying to configure something that should persist. But if you think on a machine that's running on a cloud, why would you mess with bash or RC files? You know, there's only a few reasons of a real use case that will lead you to change this. And what hackers usually do is they get access to your infrastructure, and that usually triggers a lot of stuff. So imagine that someone gained access to your infrastructure, and that triggered a lot of alerts. So people would go and try to remove the access. But the guy just did one thing. He went there and he persisted some information that will be restarted every time you open the shell again. So those are the category of attacks that are meant to persist some kind of configuration so that the hacker can leave your environment, but then with that small persistence attack that he put there, he'll be able to later gain access to the infrastructure again. So that's why one of the Falco rules is meant to trigger and notify this kind of behavior.
Cool. So now we'll be talking about how to respond an incident. So we are detecting, but how to respond? And the idea is to use the Falco talon. The Falco talon, you can just use the same Helm chart that you use to install Falco. It's just a flag that you can enable to install Talon together with Falco. And let's update our environment here. So let me just put here, just to show you that we have a flag called response action enabled true, and we have a few flags that you can put for Talon. For this case, you are just setting the replica count and nothing else. And let me install and upgrade. And let's just wait. As you can see here, we have now the Talon. And as you can see here, we have the Talon running. Let me check here why. It's terminating.
Dá uma olhada na rule enquanto isso.
Okay, so let me open here. So when I said that it's basically YAML, the rules, the idea of Falco and Falco Talon is to have something that you can easily write your rules. So here we have an example here. Do you want to talk about it, Igor?
Yeah, so that's the structure of the Falco Talon configuration. As you can see on those three lines here, we are configuring three actions. Those actions, they are pre-built in Falco Talon. So Falco Talon is basically an engine as well that, given one kind of rule, it knows how to perform some kind of action. In this case, there's one action called terminate pod, and as you can imagine, this is meant to terminate pods. There's also another action called a label pod as suspicious, and you can see as well that some of these actions, they will have parameters. So the idea is to give you a catalog of possible actions, and then based on your company policy, you would go there and you would craft your own rules, you know. So for example, for some of you here, you might be able to exec into a pod, but I've worked 5 years on a bank, for example, that no developer was allowed to access pods. So depending on the company configuration, you might be using one rule or another. And in this case, we are just defining three actions here, but we are not still saying that when I want to use them. We are just saying that they exist, and in the second step, we're going to configure, okay, when this event happens, I want to take this action, and then we have this possible list of actions. Yeah, so this is the rule configuration. Previously, we were seeing action. Now we are seeing rule. So we are saying here that whenever someone accesses a terminal shell inside of a container, and the container namespace, it's not either Falco or Cube system, because you can also have exceptions so that you can craft something that makes sense for you. we want to take one action. And the action is the one that we just defined before, label pod as suspicious. So we are saying here, whenever someone kubectl exec into a pod, Falco will detect this, it will send to Talon, and Talon will know, okay, the configuration says to me whenever someone exec into a container, I must label the container following the configuration above. So that's what it's going to do.
Okay, so let's apply again. I think I already applied.
In the list of things that you can do, we can actually show you guys later if we have a couple minutes, but the idea of Talon is to actually always grow this list, you know, so that you can do a lot of stuff. Right now we have a lot of actions related to Kubernetes, so you can drain a node, you can delete a pod, you can terminate a pod, you can stop a container, you can do a lot of things with Kubernetes. You can also invoke AWS Lambda, you can also invoke Google Cloud Function. We are right now implementing the possibility to call Azure Function as well, and the idea, as I said, is to only grow this catalog so that we can be more sophisticated in terms of how we can react to a specific event. And of course, we also have the possibility of calling webhook in case you guys want to do something very specific, like, okay, whenever someone terminal exec into a pod, I want to call my mon. You can just have a webhook doing that for you. You know, you can extend that by having the webhook there.
Awesome. So we have the Talon, we have the rule. The rule is enabled, and as you can see here, for this specific lab, we have 4 tabs here. One is to see the Kubernetes events, to see the exact time when Talon is adding a new label on the pod. We have the pod status here that you can see the labels on the pods. And we have here this one for the Kubernetes network policies for the next one. So for example, like Igor said, if I try to run an exec, so I'm inside the pod called Ubuntu. If I go to the Kubernetes events, we have a new event here. And the exactly action that Igor mentioned. So someone is doing the terminal shell, and the response that we have here is just to add a new label. And if you see here, we have a label called analysis status suspicious. So now we have an action. So we are not killing the access or anything, but we are just putting a tag to say that something suspicious is happening here. So now let me exit here. And now we want to take a really action. So do you want to talk about it, this one, Igor, while I put here?
Yeah, so in the first event, we were detecting the terminal shell container, and the action that we were taking is labeling the pod, right? In that second example, we'll be using another rule, which is a rule called outbound connection to public internet from the full namespace. So that means that whenever you have a connection from within a pod to the internet, that rule will be triggered, and then we're going to configure Talon to, after this happen in any kind of container, we're going to create a network policy. So network policy inside of the context of Kubernetes is basically a way to determine what kind of connections can be made from a specific pod, container, or namespace. And we're going to create just a block all kind of action that will block communication to all these IPs right there. So 10.0.0/8, and that should be enough to block pretty much the entire internet. That's a huge side yard block. So after we trigger that command once, the Falco will detect it, it will create a network policy, and if we try to communicate with the internet again, right after that, we should be blocked, hopefully.
Okay, so let's upgrade and try again. I'm just killing the Talon pods to get the updated configuration here. So just 1 second, we have 8 minutes. So let's wait just for 1 more minute. Come on. Almost 7 minutes now. Okay, cool. So Falco Talon is still, let me add pods here. So Talon is running and Falco is running. So now we have a different exec command here. Let me paste here. So basically what we are trying to do here is we are doing an exec command, but we are doing a curl command inside. So let's suppose that someone is trying to download a malicious Python code inside our pod. So we just have an example here. And for example, if you try to do that, let me see if I have something wrong here. That's the magic of demos. Data is not working. Let me check here if we are using the right one. Just 1 second.
Technical problem, guys. So apparently the pod doesn't have cur installed. So it's actually best practice to not have this kind of thing installed. So we're just going to use another container instead of accessing the Ubuntu one that was there. We're going to create a new container, and hopefully this time it will have it. It will not have it. It's in crash loop. In crash loop container. Sleepy. EasyBox didn't work either, but the Dodgy pod apparently does. So, and also that's the thing here. It doesn't matter where we trigger this command from. If we were running that from the Ubuntu, you could even say that it was planned before and the log was there, but now we are doing something that wasn't planned and Falco will still get it. So you see here that we have a Kubernetes event, and the only reason that we are seeing these events here is actually because tailor is configured to create an entry in the Kubernetes events whenever an event happens. But what really matters here is that the pod is being deleted because of the, not being deleted, but the Kubernetes network policy is created, and you can see here that it has a pod selector that applies only to that specific pod. So it's blocking network traffic to the internet only from the pod that executed that command. All the other pods will still have access to it, and this is also something that is part of the configuration. You could create something different to pretty much disable the entire internet access, but instead it was configured to only do this here, and then if Edson tries to run the same cur again from that container, now we should have some kind of timeout because we're going to be blocked, as you can see here. So the connection now is being refused, and that's being enforced by the Kubernetes network policy that was created by Falco tailor in reaction of a Falco event. That's the chain, basically.
Yeah, we have just 1 minute, so we'll not be able to do the last one due to the issues that we had. I don't remember the last time that I had to run a pod directly without a deployment. Maybe on the certification. But yeah, that's all, folks. What we are trying to do here is to show to you the power of an open source tool that is behind the CNCF umbrella, and you can play a lot. The documentation, the website is falco.org, so you can see some good examples, some good blog posts, and a lot of use cases that we can use. And I think that's all. We still have another one, but you can try later. And that's all. Thank you so much for your time. And if you have any question, we will be here. So
Yeah, you can ask any questions before someone kicks us out. So
yeah, thank you so much, folks.